So last class we have performed amplitude shift keying. Okay, today we are going to perform frequency shift keying. So frequency shift keying, just you can see there is a one change only. So here the data signal is connected to FSK the same way, and just we will select the mode button at FSK and mode button in SQ format and modulation button as FSK here on the board. So I will select this in SQ format and this in FSK. Okay, so this is the circuit. Here we are grounding this to with the board. Okay, here the trigger is connected to the sink, and Y1 channel is we are giving to the data signal, and Y2 channel is we are giving to the modulation output. Okay, this is a circuit connection. Okay, so as you know that FSK, so like frequency modulation, when the data bit is high, you will get the more number of pulses, carrier pulses, oscillation pulses. Okay, when the data bit is low, the frequency is decreasing, that means time period is increasing here. Okay, here the frequency is reducing, that means time period is frequency is increasing, that means time period is reducing. Here frequency is increasing, decreasing, and time period is increasing. Okay, so you can see this. So we will verify this with our experimental part. So let's make the connection is done. Let us go with the procedure. So again, the board we are going to use is modern technology 70074 board. Okay, so here you can find the steps. So modulation button to SQ format and mode button to SQ format, and the modulation button to the FSK format. Oscillation, open the oscilloscope here and make it 500 micro. Okay, make the continuous operation. Okay, we got our output here. So you can see here, so in the first positive half, so that means 1, when the data bit is 1, you are getting 8 oscillation pulses, and when the data bit is low, that means you are getting 4 oscillation pulses. Okay, just see the output. So here you can write number of oscillation pulses in the carrier for logic 0 bit is how much? For the logic bit 0 it is how much? 4, and the logic bit 1 it is how much? 8. So this is the modulation part. Let us go to the demodulation. First we will see the data spectrum again. Okay, to see the data spectrum, where we go, we will just close it and open the oscilloscope 50 move again. So let us take Y1. So Y1 will be same like the previous thing, because here data frequency is same. Frequency of the data signal is same. So it will be 0 points like the previous. It is 0. Okay. Now it is 0.6 kilohertz. You can see here. Okay, 0.6 kilohertz is your data frequency. Next will be 0.3 into 0.6 into 3 will be around 1.8, and this is 3.1. The multiplication factor of 3. You know that this thing from the amplitude. We have done this from the amplitude shift amplitude modulation. Okay, pulse amplitude modulation. So this is the data signal. So here just click Y2 y2 here and just take the modulation spectrum. Okay, so here you can see two things. Okay, f0, this is 0.6 kilo 85 kilohertz and this is 8.1. so this is your first center 9.95 and this is 10.6 f0 minus fd, f0 plus fd, and this is the shifted version. Okay, so this is at 5 and 5.6, 0.65 plus data signal is 0.6. Okay, 5 is the center frequency and this is 5 minus is 0.35. Okay, 0.65 is your data signal, frequency of the data signal. Okay, so here you control this to 5 center f0 minus fd. This is nothing but shifted version, so frequency shift. So that's why you are getting in the whenever the data bit is 0, you are getting 4 bits. Whenever the data bit is 8, you are getting how much? 8 bit. So this is the shifted version for the 0 part. Okay, hope you understand. Just complete the experiment. Okay, we are left with the demodulation part. For the demodulation, again what we need to do is we will remove this and we will connect to the FSK. Let us go back to the circuit again here. Close this. So here you can see delta F, F1 and F2. So this is delta F, this is delta F. F0 is the center frequency. Okay. So this is the demodulation part. So we'll connect. Okay, so here it is. We have to short this like this one. We'll short this and Y1 we will connect to the output of the filter, so the rectifier, and to the FSK demodulation output. This is the circuit, how it looks like. Just again. So now, same way, follow the procedure of the ASK. So in the modulation format, select SQ, and the demodulation format, select FSK. Okay, select FSK here, modulation to FSK. So let us follow the procedure again. With the modulation button located on the board to select SQ format, and the modulation button located on the board to select FSK. Oscilloscope external trigger, activate the continuous mode and signal behind the filter. Oscilloscope and make it 200 micro and select these two channels, and you will get the output as. So this is the modulated when the data signal is 0. So demodulated signal will be like this. Okay, and when the data bit was 1, you will get the carrier data signal same like there is no loss. Okay. you can draw this. So here we complete our frequency shift keying. Next class, when you come to the class, we will perform phase shift keying. Okay. If you have any doubt, you can write in the course message, or you can just discuss in the lab. Thank you.